Hi, boys and girls, and welcome back to A Splinter of Winter, Fraction Wonderland. We are in Chapter 8, and we're almost done learning about multiplying and dividing fractions. Here in Lesson 8.3, we need to understand that fractions represent division. As you can see, our goal is to solve real-world problems using fractions as a representation of division. I think you're going to find this very interesting. In this lesson, focus on using, please, perseverance. That's extremely important. When you're trying to solve the problem, never give up. You will eventually master the skill or even solve the problem on your own. Pay attention to precision. We've been doing reflex math because we need to know our math facts. It makes it a lot easier for us to persevere when we're solving a problem. We might have an opportunity to construct viable arguments or critique the reasoning of other people. We should always be modeling with mathematics. Even if we're doing it in our head, we should see pictures or equations that represent the problem. Now, if you are modeling in your head, it is always beneficial to write down what you're seeing so that your teacher knows what strategies you're using. So, fractions do, in fact, represent division. Here is a picture of that so you can see, or I would call it an image of a bunch of text. You can see what I mean when I say that. Now, you might be thinking, oh my gosh, Miss Addison has these equations up here. I have no idea what she means. Let me show you. 1/3 is the same thing as saying 1 divided by 3, okay? And we see that right here. I wanted you to understand that 1/3 is the same as saying 12 divided by 36. The reason why, I'll show you down here, is because 12 divided by 36 is the same thing as saying 12/36. And when we simplify this fraction by dividing the numerator and the denominator by 12, it will equal 1/3. So I wanted you to understand that when I say 1/3, that means 1 divided by 3, but it could also be 12 divided by 36 because 12/36 and 1/3 are equivalent fractions. And here you'll see some more equivalent fractions, 2/6, and it doesn't matter which side of the equal sign the numbers are recorded. Let's look at an example of what this looks like in real life, okay? Stanley took a math test. We're all familiar with those. His score was a 17 out of 21, or 17/21. He entered the following into a calculator to figure out his grade. Wait, what? I can enter these numbers into my calculator and figure out what my grade is? You sure can. So he typed 1/7, then he hit the division button, then he typed 21. Lastly, he pressed the equal button, and this is what Stanley saw. 0.8095238. Stanley's teacher rounds up, which we've learned this before. We've probably started learning this in like second grade, that we look at the number to the right, and if it's greater than 5, we round the number or the digit to the left, we round that digit up by 1. So that's how we came up with 81. Because when we're looking at a grade, we're looking at these first two numbers after the decimal point. So we could say that Stanley's grade is an 81% or 81/100ths. And I've written that as a percent, as a fraction, and in words, just so that you can make the connection between all of the math you're learning. Fractions are decimals, decimals are fractions, okay? So you can start doing this on your own. Let's look at an easier example. Let's say Stanley got 8 out of 10 on a vocabulary test. That would be an 80% or we called it 80 points, which is the equivalent of 80/100. This is why we call it an 80%, or you might say, oh, you got an 80, that is a B. Neat, isn't it? Okay. Nathan and Charlie are being measured for their karate uniforms. You're going to see me using cubes as I solve this problem because that strategy is extremely important. Even though they wear different sizes, each boy must send at least 6 yards of fabric. Whoa, that doesn't sound right. Let me use my editing skills here. Even though they wear different sizes, each boy, don't need the word will, each boy must send at least 6 yards of fabric to the seamstress. Nathan's mom gave the seamstress a total of 13 yards of fabric to be split evenly. That's an action word. How much fabric will each boy have if the 13 yards are split evenly? Now, there are 2 questions here. Is there enough for both boys? Okay, what do I visualize? I see a long piece of fabric, and it's 13 yards. And she says that the fabric must be split evenly between 2 boys. So that means I probably have to cut it in half. But what does that look like as an expression? It looks like 13 divided by 2. I have 13 yards of fabric, and it must be divided for 2 boys. If I were to represent these with letters, I would say, okay, the 13 is yards, so I would call that Y, and the boys, I would call them B for boys, Y divided by B. Well, Y, which is the yards, is 13, and B, which is the boys, is 2. But what I don't know is how much each boy will get. So I'm trying to figure out what E is. E, I'm going to say, stands for each boy. I need to figure out what 13 divided by 2 is. Well, I know that 13 divided by 2 is also a fraction. Oh yeah, I'm just asking myself, how many times does 2 go into 13? Each boy will get 6.5 yards. How do I know that? If I needed to, I could do my division over here to the side. 2 goes into 13 6 times. 6 times 2 is 12, and I have 1 left. My remainder and my divisor will be used to create a fraction. So each boy has 6.5 yards used by the it is enough. But I need to explain why it is enough, and I am going to use numbers to do that. Here is my explanation. Now, boys and girls, this is extremely important because the more advanced you get in math, you can use numbers to display your thoughts, sometimes instead of words. I didn't ask how you solved it, but I said explain. And so sometimes we can use an expression, or this is actually an equation, to show that. We have the 13 yards. I could even add more. Divided by 2 boys is 6.5 yards per boy. Let's try this one. Why don't you pause the video if you want to, see if you get it right. That way you can use the we do and the you do as your practice. Blake has 2/3 of his vanilla birthday cake. Oh, that sounds good. Yum. left from a party. Okay, so it's left over, not the whole cake. He wants his 2 dogs, oh, that's nice, to share it. How much of the cake will he give to each dog? Well, there are 2/3 of the cake left, and he's going to share it with his 2 dogs. So he wants his 2 dogs to share it. He's not going to share it with them. It says, write an equation to represent the problem. Well, we don't know how much of the cake he will give to each dog. That's what we're trying to find out. So we could use an E or a D. I don't really want to use a D because D might represent the 2 dogs, and then 2/3 represents C, which is the cake. Does that make sense? Okay, so we want to divide 2/3 of the cake into 2. Does anyone remember how to do this? Right, I bet you do. So we can draw a picture. And if you'd like, you can watch the next video where I show you how to use a trick called keep, change, flip. You only want to do that if you understand what you're doing in the first place. So we have 3, but we have 2/3. And he's taking those 2/3 and splitting them in half. All right, so how much of the whole thing, this is what each dog will get. How much of the whole thing will each boy receive, or each dog, not each boy. How much of the whole thing will they receive? Exactly, they will receive 2/6. How did I get that? Well, there's 1/6, 2/6, 3/6, 4/6, 5/6, 6. They're going to get 2/3. If there were 2/3 left, and each of them is going to get half of those 2/3, each one will get 2/6, or we could call that 1/3 because we simplified it. So we would say 2/3 divided by 2 equals 1/3. Each dog will get 1/3 of the cake. And the reason that's true is because the question we were asking is what fraction of the whole cake? This is the whole cake. But what Blake had left was just the 2/3. He took that 2/3 and split it in half, and that's the part that's all black. I hope that makes sense. Finally, solve this problem on your own. Pause the video, and I'll come back with the answer. Uh-oh, hopefully you're using your editing skills and you see an error. She wants, we're going to scratch that out, it's unneeded. She distributed them evenly amongst her 7 friends. Great, pause and continue to solve. Okay, you should be able to see the answer here. Our equation is here. Boys and girls, we should be adding the knowledge that we have from chapter 1 about the order of operations, understanding what that looks like. So she had 3 dozen churros. A dozen, we should remember, is 12. So I have to start by saying 3 times 12 is 36. Then she's going to take those 36 churros and divide them amongst her 7 friends. Here's what that looks like as a fraction. And here is the fraction written as an expression. Okay? Each friend is going to receive 36/7, or we could say they're going to receive 5 whole churros and then 1/7 of another. And then if you look at the picture, I have that here. So this is a friend, and that friend is 1, 2, 3, 4, 5 churros, and then there's 1/7 of that last one that's left over. Okay? Hope you got it right. Let's take a look at our scale for home. If your practice problems were correct, you're right where you need to be. If not, note where you are in your scale and receive the help you need tomorrow. Thanks for watching.